Hello dear friends, welcome to our tutorial videos, and in this video what we are going to be doing or what we are going to be solving is a question on circle geometry or circle theorem or circle properties. Okay, so looking at this question that we have, what you are supposed to do is you have to know the theorems that you can apply to solve this question. Okay, so now looking at the question, before we actually go to the solution of these angles that they've asked, we can first of all calculate some of the angles that we can calculate using some of the theorems that we can apply. Okay, so let us try to solve some of the questions that we can solve. Okay, so now let's start with this angle here. Okay, we can find this angle by using the theorem which states that when you have a circle, okay, and you have a diameter is a line that passes through the center O. Okay, so this is a circle and we have a diameter, a line which passes through the center. The angle which is subtended from the diameter, or the angle that is coming from the diameter, is equal to 90, or simply the angle formed in a semicircle, half of a circle. So if this line passes through the center, meaning this is half of a circle. So the angle formed in a semicircle is equal to 90. Okay, so we can find this angle because this is a diameter. Okay, and since this is a diameter, meaning all this angle here is 90. Now for us to find this angle, we are simply going to subtract 90 minus 26 degrees. Okay, and that is going to give us 64 degrees, meaning this angle here is 64 degrees. Okay, so we found this angle. What other angle can we find? So we can also find this angle by using the fact that, so let me rub, by using the fact that angles in a triangle, if this is a triangle, the angles in a triangle, when you add all the three angles, you get 180, meaning that this angle or this angle plus this angle plus this angle adds up to 180. So for me to find this angle, I am simply going to subtract the sum of these two angles from 180. So 180 minus 42 plus 26 plus 64, in short 42 plus 90, you have 132. Okay, if I subtract 180 minus 132, I am going to get 48. Okay, so this will give me 48 degrees. So this angle is 48 degrees. Okay, what other angle can I find using the theorems? There is a theorem which states that the angles coming from the same chord, let's say this is a circle. A chord is any line that comes from one end of the circumference to another. So this is a chord. Let's say this is a chord. All angles coming from this chord are going to be equal. So let's assume all those are straight lines. So let me grab this. Okay, so this is a circle. This is a chord. All angles coming from the same chord are equal. Okay, let's say all these angles. You can actually have more than two. So this angle and this angle will be equal because they are coming from this same. Okay, so let's say this is code AB. The angles coming from this chord are going to be equal. So this angle and this angle are equal. So let's apply this on this chord. As you can see, RQ is a chord. And we have this angle, and this angle coming from the same chord, which is RQ. Meaning if this is 42, this is also 42 degrees. Okay, apart from saying angles coming from the same chord, you can also say angles coming from the same segment. So let's say this is there is no chord, but this is a segment here, a segment. Okay, angles coming from segment A, B are equal. Okay, so I can apply, this is a segment here, this segment S P is a segment, meaning this angle and this angle are going to be equal because both the angle at Q and the angle at R are coming from the same segment. Okay, so this is also 26 degrees. Okay, so we have at least found some of the angles that we can easily find using the theorems that we have. One last angle or one last theorem that we can apply here is the alternate segment theorem. Okay, so if you have a circle and a tangent is a line that touches the circle at one point. So this is a tangent. If you have a triangle inside, okay, if you have a triangle inside and the cyclic triangle touches the tangent, so this is a tangent, okay, and we have a cyclic triangle. The alternate segment theorem states that this angle will be equal to this angle. Also, this angle will be equal to this angle. Okay, in short, how easily you can look at this is this angle is looking at this angle. Okay, this angle is looking at this angle, meaning they are equal. This angle is also looking at this angle, meaning they are equal. Only and only if there is a tangent and one point of the triangle touches the tangent or meets the tangent. Okay, the alternate segment theorem states that this angle will be equal to that, also this will be equal to that. But the triangle inside the circle must be a cyclic triangle, which simply means that all its three corners or all its 3 points or vertices must touch the circle. Okay, so let us apply this on this tangent. Okay, this is a tangent, meaning this angle is looking at this angle when we look at this triangle here, triangle PQR. This angle is looking at that, so meaning these two are equal. Also, this angle or this angle is looking at this angle here or this angle, which is 90, and it's true. Okay, so this angle is equal to 48, so 48 degrees. So we have applied all the visible theorems. We can now answer the questions that we have. So the questions are: calculate PRS. PRS is therefore going to be, so let's check, PRS is 26 because it's equal to that angle there. So PRS is 26. Okay, which other angle have they asked? PRQ. So this angle is 26. We come to angle PRQ. 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 PRQ is 48 because this angle is equal to, we found it by adding this plus this minus 180. So this angle is 48. So PRQ is 48. So these are simple things. PRQ is 48. PRQ is equal to 48 degrees. And the last angle is PTQ. 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 So they want that angle there. So they want us to find this angle PTQ. PTQ is going to be found by applying the fact that all this angle we found to this angle is equal to all this angle here, which is 90 degrees. Okay, another theorem that you can use is the theorem that when a radius meets a tangent, they meet at 90 degrees. So OP is a radius and it meets the tangent at 90 degrees. So theorems must be known. Okay, so we have all these angles. So when we look at all this angle plus this angle plus this angle, they'll give us 180 because this is a triangle, triangle PTQ. So using triangle PTQ and the angles in PTQ, so we know that this angle plus this angle plus this angle adds up to 180. So to find angle at T, we will say 180 minus 90 plus 42 plus 26. So 90 plus 42 is 132. 132 plus, so 132 plus 26. 132 plus 26, we're going to have 158. So 180 minus 158. So 180 minus 158, we're going to find this angle to be equal to 22 degrees. So this angle will be 22 degrees, meaning the angle at T, which is PTQ, is 22 degrees. So that is only circle theorems. Make sure you go through the theorems, watch the video and see how I am applying the theorems, and you will understand these circle properties and how to deal with questions on circle theorems. Thank you very much and stay blessed.